Hi, everyone. My name is Nate Fisher, and I'm from the Android WebView team. So we're here for Android WebView 101. And the idea of this talk is we're going to cover what is Android WebView? How is it different from Chrome? What is Android WebView even used for? Why do people care? Why you should care as a Chromium developer, and how we can get started working on WebView and contributing to it. So without further ado, I think the right place to start is uh, our team's mission. So our team's goal is to bring the best of Chromium to the Android platform. We want to bring this in a reusable, componentized way. So Android WebView is a component which Android apps can embed. It is a rectangle that just shows a web page. I'll get a little more into that in a moment. But this is something apps can take advantage of to use all the cool Chromium features that we work on day in and day out, like multi-process browsing, the V8 JavaScript engine, all that good stuff. Uh, from another perspective, we as web platform maintainers might interpret WebView as a sixth platform. So if you are trying to ship something in Blink, you may be asked if your feature will ship on Windows, Mac, Linux, Chrome, Android, and Android WebView. So there is a distinction there, and we'll get a little bit into that. Okay, but really, what is this thing? Android WebView is a part of what we call the Android framework. This is the canonical framework that comes with the Android OS for building Android apps. So it is a Java class called android.webkit.webview, and you might add this to your app's view hierarchy. An Android view, simply put, is just a rectangle that shows up on the screen. So you might have, let's say, a rectangle at the top that accepts text, and this might be like a URL bar. You might have a very large rectangle that shows the web page, and you might have some rectangles at the bottom for maybe a back button or something like that. And we might be talking about a browser or some other app of that sort. But we are so much more than just a rectangle. We also have hundreds of APIs that we offer and support, many of which are browsing related, such as load URL. This is an API unique to WebView. It loads a URL and starts navigating to that page, some of which are kind of your standard run-of-the-mill view APIs. I won't focus as much on the standard Android view stuff, but I just wanted to lay the ground that this is part of Android framework. But let's dive into what is WebView actually good for. It turns out a lot. The web is a very successful platform, and it is used in places you can hardly imagine. So we've identified more or less 4 basic use cases for WebView. And I'll start with actually the second use case that we have here, browsers. So this is kind of an obvious case. WebView is a rectangle that can show web pages. Browsers need to show web pages. Okay, no big surprise there that someone might choose to use a WebView to support this because it comes with Android, and you get this functionality for free. But we have some other use cases that may or may not surprise you. We have this case called embedded into app. So what you see here is Gmail. That is the contents of an email, because emails can be somewhat arbitrary HTML. So it makes sense to use a web engine to parse and render that. The third thing here is called Cordova. There's a similar offering called PhoneGap. The idea here is there's a bunch of skilled web developers out there who may not have familiarity with Java or the Android framework, but they still want to make an Android app. So the idea is the Cordova framework is just one big web view. And you write a web app, and this web app lives inside of that web view. And all of the business logic for this app happens in JavaScript. All of the UI is HTML. All of the styling is CSS, just like you would see in a standard run-of-the-mill web app, except this can be installed through the Play Store. And a very big case for WebView is advertisements. On the open web, we see advertisements are often shown inside of iframes. In Android apps, web views typically take the place of those iframes. You have web views that are embedded in all shapes and sizes in mobile apps. So something that I think is kind of fun is to take a look at these 4 pictures and decide which of these are web views and which of these are not. So we have here the Google account sign-in that is part of the setup wizard on Android. We have composing in email in Gmail. So we already saw that viewing an email is HTML, but here we have a text field for composing. And we have opening links in Gmail. So this is if some email links out to a website and you follow that. And then we have clicking on a link in Facebook. So the answers are 3 out of the 4 of these are WebView, perhaps in ways you may not expect. This Google account sign-in is actually WebView. It feels very much like it's just a regular part of the Android system, but it turns out this is actually all HTML. It just goes out over the internet and loads a web page in a web view. A really weird use case is the Gmail Compose. So it sort of makes sense that we can use Gmail to show emails because they are HTML content. But it turns out you can use WebView in Gmail to compose emails. As you're composing the email, you're actually writing a DOM. You're editing this DOM on the fly, which is kind of an unusual way of experiencing the web. But it turns out to be quite popular for mail apps. Clicking on a link in Gmail is actually not a web view. Even though we're loading a web page, it seems like kind of an obvious use case for a web view. This uses a different technology called Chrome custom tabs, which I won't cover too much in this talk. But interestingly, if you're on Facebook and you're scrolling down your newsfeed and you click on a link that your friend posted, this is a very similar user journey to the Gmail user journey, but it actually uses WebView. It does not use Chrome custom tabs, even though they actually look quite similar. Okay, so now that we understand a little bit of some of the use cases, I want to stress that there's so many more out there. WebView is used in a large variety of cases by nearly every, by a large proportion of applications, I should say. And WebView is present on every single Android device because this is part of the standard Android framework. So there's quite a large opportunity for impact. All right, so now that we've covered briefly what is WebView, maybe from a user's perspective, let's go a little bit into WebView from an app developer's perspective. What can this do? So I've picked a few APIs here. This is by no means the full offering, but we have load URL. This is a Java method that an app developer might call, and this is more or less analogous to if the user input a URL in the Omnibox and navigated to it. So this initiates what we call a browser-initiated navigation. We also offer some callbacks to the app to let it know the state of the navigation. On page started and on page finished are two of these, and an app developer might hypothetically use these to update the state of the Omnibox as we go through different redirects and as the navigation fully finishes. And then we also have some error callbacks that let the app developer know if something went wrong. These would be network errors or HTTP errors like 404s, for example. But there are some even more interesting APIs, and this is, again, by no means the full offering, but we have evaluate JavaScript. This is a way of executing arbitrary JavaScript code. The app developer can execute arbitrary JavaScript code in the context of the web page. We have APIs that give full access to the cookie jar, and we even have an API that gives full access to the Chrome network stack, or I should say the Chromium network stack that's part of Android WebView. So this lets app developers modify any requests or intercept requests or even block requests. So now that we have some idea of what WebView can do, I think it makes sense to dive a little bit into what WebView is, how does it work, and perhaps this will address some of the potential concerns over all this access that we give app developers to the networking stack and the web loading process. So the first thing I want to talk about is the trust model for Android WebView. We consider the app to be completely trusted. And in fact, the browser process that you might be familiar with in Chrome is actually the application's own process. So all of our browser process code runs in the same address space. An important aspect of doing this securely is that we make sure the browser process only has the exact set of permissions that the app itself does. And that means each app that uses WebView will have its own copy of the WebView cookie jar, or it'll have its own profile, etc. So these are things that you would usually think of as one per browser process. That's still the case, but in the world of Android WebView, there may be multiple browser processes if there are multiple apps running. And I mentioned before, android.webkit.webview is a Java object. There's nothing to prevent you from creating multiple of these. We think of each WebView as more or less the same as each Chrome tab. So just like you have multiple tabs in Chrome, but only one Chrome browser running, you can have multiple WebViews in an app. You only have one, what we might call WebView session. One of the interesting drawbacks of WebView being an Android view is that we get to implement everything that is required of views. So in particular, Android WebView offers something called synchronous drawing. This involves a lot of blocking graphics operations that Chrome may not have to do. WebView has to do this because we have to report the exact state of our drawing back to the operating system so that the application knows what's going on. But it has some advantages where you can synchronously scroll a web view with other Android views in the view hierarchy. There's no lag between this. For some use cases, this is very desirable for applications. Another interesting case is that when the Android platform adds new features such as smart text selection or text magnifier or autofill, WebView is expected to also implement these. So this is a fair amount of work on our end from our team. But my favorite thing about being part of Android frameworks is that we get to create APIs. So we get to expose APIs for all the really great web platform features like Service Worker. We have something called Service Worker Controller, which is a Java class that gives the application the exact amount of control they would need over a service worker to be able to use it effectively. And I think this is a really interesting aspect of being part of the Android WebView team. So I've alluded to this a little bit, but WebView is part of Chromium. Specifically, we are what we would call a Chromium embedder. This means we use the content layer the same way as a project like Chrome might use the content layer. So if you're familiar with this diagram, it's slightly outdated now, but I couldn't find a more up-to-date copy of the diagram for this talk, unfortunately. This is the layer cake of Chromium. We have Chrome browser as, or the Chrome folder, if you will, as the top layer. Right beneath that is the content layer. We have things like the network layer, we have the base layer, we have Blink, V8, things like this. So you can think of Android WebView as taking off that Chrome layer and replacing it with an Android WebView layer. So we're still going to use content, we're still going to use net, we're still going to use base, we use all that same stuff that Chrome does, just not the Chrome folder. Instead, we have a different folder, the Android WebView folder, that you can find in the top level of the Chromium checkout. And an interesting consequence of being a content embedder, of course, we get to inherit all these really great Chrome features that are built in content layer and below, like network service and things like that, or multi-process browsing, etc. But it also sometimes requires a lot of work on our team to make sure we correctly support this in the necessary timeline. Network service is a recent example that comes to mind, where our team had to step in and do a little bit of work to make sure that all of WebView's many APIs work correctly with network service, so that we could remove a dependency on the old code path, that we could clean up all those hundreds of thousands of lines of code. At runtime, so that was kind of an overview of our code layout architecture, but our runtime architecture is also worth covering. So this is not WebView's architecture. This is Chrome's architecture. It's actually a simplified version of it. So you'll notice we have the one browser process. We have a handful of renderer processes. We have a network service process and a GPU process. So hopefully this is more or less familiar. But those who aren't too experienced with Android may not be aware that on Android, we have a slightly different process sometimes, a slightly different architecture. We have what I call the low memory architecture. There's certain overhead for each of these processes. So what we do is we run some of these services in process, which specifically means in the browser process instead of their own separate process. So you'll see we still have the 3 or so renderers, but we have this browser process, and we still have the network service and GPU service, but these are part of that same browser process. So Android WebView is not too far off from that. On Android O and above, we have something that we call multi-process mode, but I think it would be more accurate to say out of process renderer. Out of which process? Out of the browser process. We have the separate dedicated renderer process. So this is almost the same as the previous diagram, but we only have one renderer process. No matter how many web views we have, they will all share a renderer. And the browser process is, again, the same as the apps process. So they're going to share the same address space. And we're still going to have the network service in process and the GPU service in process. We also have an architecture called what we call single process mode, but it may be more accurate to call this in-process renderer. This is what happens on Android L through N. There's some architectural, there's some architectural limitations of the operating system that prevent us from shipping a separate renderer process on L through N. So we run the renderer process in the same process as the browser, and everything's just one big process. So this is a little different from Chrome, but hopefully you can see the tweaks that got us to this condition. All right, so we should have more or less a picture of what WebView is, at least at a high level, and how it differs from the Chrome browser. I'd like to jump into what it means to work with WebView and tell you a little bit about some of the past projects we've done here on the team. So the developer workflow is, I think, very similar to Chrome for Android. It all happens in a Chromium checkout. You just need either an Android emulator or a user debug phone. And you can go to go WebView docs/quick start, or you can just find this file in the Chromium checkout. It's under Android WebView/docs. So I encourage you to check that out. I think it's not too hard to get started. And of course, I've been talking about all these APIs WebView offers. WebView, of course, itself is not very interesting. It is a library, but if you have an app that exercises those APIs, now you can start doing some interesting things. So we also have a test application called the WebView shell. It is a thin browser type application just to exercise the very basic surface of the APIs. So you can go and check that out as well. That's also in the Android WebView/docs folder. So launching features on WebView sometimes just makes perfect sense, but sometimes there are some interesting design challenges that we face. One design challenge we faced a few years back is bringing safe browsing to WebView. So I mentioned that WebView can be all shapes and all sizes, especially for the ads use case, but even for a lot of other use cases. So what you see here are 4 different web views in this left screenshot. These are wide and short. They're stacked on top of each other. So when we were launching safe browsing, we noticed that the standard red safe browsing interstitial would get cut off, and it was really hard to read. So we got to redesign interstitials to have what we call the small interstitial, or the quiet interstitial, it's sometimes called. It's this gray blocking page that you see in that rightmost screenshot. So that was an interesting design challenge. In general, WebView may operate in a mode where it doesn't have internet access. This could happen if the app is injecting its own HTML, which is something we support. WebView may be operating in a mode where it can't create pop-ups. So these are all things to keep in mind, and I encourage you to reach out to the WebView team if you have any questions. Our release cadence is the exact same as Chrome for Android. In fact, we are actually the same binary as Chrome for Android on some operating system versions. I don't have time to get too into that, but you can just look at the standard release process for Chrome for Android to figure out when the next WebView release goes out. And one of the consequences of this means that if you do need to respin for Android WebView, that will mean respin for Chrome for Android. So that's something to keep in mind if you're launching a risky feature. I'll get into experiments and metrics very briefly. We support metrics, also called UMA. The platform is called Android WebView. We also support field trials, which some of you may know as variations, or Finch. Again, the platform is called Android WebView, this time spelled a little differently. WebView automatically can detect features that have been declared in lower layers. So if you have a base feature that is defined in the content layer, WebView automatically picks that up, just like Chrome would automatically pick that up. But it also defines a handful of features and flags of its own. So that's something you can do if necessary. All right, so I think that just about wraps up my content. I just wanted to remind you again, if you are launching web platform or architectural change features for Chrome, please consider Android WebView. We are a member of the Chromium ecosystem, and we'd be more than happy almost all the time to accept these features and work with you to get them working correctly for Android WebView. All right. So I think we can go to questions. Okay. What are the main differences in security guarantees / features in Android WebView compared to Chrome for Android and desktop platforms, such as site isolation? So site isolation is not supported in Android WebView in particular because this would require multiple renderer processes, and we don't support multiple renderer processes yet. Although hopefully we could support this in the not too distant future. We have no immediate plans for that, but it's something that I think could happen in principle. More generally regarding security, the two things that I would like to call out are, on some operating system versions, Lollipop through Nougat, we have an in-process renderer. So in that case, that would be running in the browser process, which is actually in the app process, and loading any untrusted content would pose a security risk. This is mitigated on Oreo and above, the more modern operating system versions where we have the separate renderer process, but we still only have one, so all the sites will be mixed together. And then the other thing I'll say is that a compromised browser process in Android WebView would mean not just that the browser process is compromised, but potentially that the whole Android app process is compromised. Okay, I'll go to the next question. So, is there a roadmap of upcoming WebView APIs / features, especially those which improve parity with Chrome for Android? We don't have any public roadmap. Our team does do the usual planning processes within Google, but we don't have any sort of public roadmap for the features we're planning to add. That might be something we can look into. For the features which are already planning to launch on WebView, for example, there's a web components v0 deprecation. This is launching not just on Chrome, but also on WebView. And I believe that is published on the Blink launch site, the standard site for Chrome launching web platform features. It would just list WebView as another platform. So that's probably the closest thing I can think of that would resolve that. And then our last question, will WebView get auto updates like desktop Chrome? So we ship through the same way as Chrome for Android, which is through the Play Store. which is the App Store on Android. And this does do auto updates, although I'm not sure it's the type of auto updates you are thinking of. This does auto updates in that the Play Store will automatically download and install a new version as it's available, but it won't automatically provide any in-product branding. It won't, have a warning message that say your Chrome is 5 days out of date. Make sure to update it. Okay, if that is everything, then uh, I think we can jump out and uh, get ready for the closing remarks and then go off to lunch. All right. Bye, everyone.